Okay, so today's lesson is multiplying and dividing rational expressions. So yesterday we were focusing on simplifying them by factoring numerator and denominator and canceling. Now we're actually multiplying and dividing those rational expressions. Okay, so first of all, when multiplying fractions, you multiply the numerators by each other and denominators by each other. So essentially that just means top times top, bottom times bottom. When dividing fractions, though, you take the reciprocal of the divisor and then multiply them. So that just means whatever you divide by, flip it, and then you multiply by that. So that's kind of like how dividing by half is the same as multiplying by 2, or dividing by 2 is the same as multiplying by half. Okay, so let's just look at it with simple fractions first. So I don't have a tablet or anything, so hopefully this isn't too messy, just doing it with the finger pad on the laptop. Okay, so top times top, bottom times bottom. What that means is you would get 2 times 5, and that's on top, and 3 times 7 on the bottom. Okay, so fraction times fraction, it is 10 on top and 21 on the bottom. Does that reduce? And it doesn't. 10 over 21. Okay, next one. So this is what we're talking about. When you divide fractions, and we'll be doing that with rational expressions, I don't know what that was, you write out the first fraction, so 2 over 3, but now it's going to be times 7 over 6. Okay, so top times top, bottom times bottom. Now I could cancel out at the beginning here. So for instance, 2 and 6 have something in common. They can both be reduced by 2. So we can maybe try that for another one. For now, I'll just do top times top, 14 over 18. Okay, so what does that reduce to? It reduces to 7 over 9. Okay, now, here was what I was just talking about, how you can cancel stuff out at the beginning. So for example, you've got 5 times 16, 4 times 15 on the denominator. So however, though, 5 and 15 can both be reduced by 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. So that can be changed to 1 over 3. Because remember, top times top, bottom times bottom, they're going to end up being, one's going to be a numerator, one's going to be the denominator. So they can cancel. They can reduce. 16 and 4 can be reduced by a factor of 4. So 16 divided by 4 is 4. 4 divided by 4 is 1. Now remember, there's no plus minuses here. So we can do this. We can reduce each term. Okay, 1 times 4 over 1 times 3. 1 times 4 is 4. 1 times 3 is 3. Okay, so we could have done that with B. We could have gone 2 and 6, reduces down to 1 and 3, and would have got 7 and 9 right away. Okay, so that's multiplication, division with simple fractions. So now let's look at how does this work with rational expressions. So here's a simple case. 2a squared over 5b squared over c times 3b squared over 8a squared. Okay, so you can see there's going to be some restrictions here. B and C can't equal 0, A can't equal 0, nothing, the denominator can't be 0. Okay, so first let's try it where we multiply everything together. So top times top, bottom times bottom. 2 times 3 is 6. A squared on top. That's squared. B and C squared. Okay, the denominator. So before we cancel anything out, we're doing top times top, bottom times bottom. The denominator, 5 times 8, you're going to get 40. A squared, so that's the only A term, so A squared, and I'll just put it in the order of A, B, C. A squared, B squared is left there, and C. Okay, can that reduce? So 6 over 40 does reduce. You can reduce that down to 3 over 20. Okay, so there's no exponents on these coefficients. It's just 6 over 40 is the same as 3 over 20. Now, a squared over a squared. Okay, that will cancel out. So that will turn into 1, which we don't have to write down. B over b squared. That will be, a b cancels out here with a b down here. So we're left with a b on the denominator. Okay, or you could say b to the minus 1 which means it would go to the denominator. And same thing here, c squared and c, cancel out a c, cancel out a c from the c squared, we're left with a c on top. Okay, so the answer is 3c over 20b. However, we have to state our restrictions. So b can't equal 0, we can see. But remember, go back to the beginning, and I said a can't equal 0, b can't equal 0, and c can't equal 0. So that's b can't equal 0, c can't equal 0. Okay, so all our restrictions. Don't know why that's popping up. Okay, any questions? Oh wait, I can't answer any questions because I can't see you. Okay, x squared minus 9. So this is example 3, multiplying rational expressions. Simplify and state restrictions. So kind of the step we got to do here is first put brackets around numerator and denominator. This whole numerator is being multiplied by this whole numerator. Okay, so it makes it a lot easier if we just put brackets around them to make it clear that it's bracket times bracket. Okay, so we are multiplying numerators and multiplying denominators. One of the first things we can do is factor, because once we factor, we can see if anything cancels out. So x squared minus 9 is a difference of squares. X plus 3 and x minus 3. Okay, look at the denominator, 2x plus 4. That is a case of common factoring. Okay, so what can I factor out? Yep, you are correct. Whoever said 2, pull the 2 out, and x plus 2 is what I'm left with. Okay, and I'm left with times x plus 2 over x plus 3. Okay, so now that I factored it, a factor can be canceled if it appears in the numerator and denominator. Okay, because remember, these two these two fractions are being multiplied together. Okay, so bracket times bracket times bracket over 2 times bracket times bracket. So, is there anything common? Yes, there is. X plus 3, x plus 3, x plus 2, x plus 2. So, it in fact simplifies down to x minus 3 over 2. Okay, and then always state final answer and restrictions. Here, looking at this, there's no restrictions, but of course you have to go back to the original. What do you factored? X plus 2 can't equal 0, so that means x can equal, okay, minus 2, and also x plus 3 can't equal 0. Okay, so we can write them all together with a comma separating them, and we usually put lowest number first. So minus 3 is a lower number than minus 2. Okay, so it equals x minus 3 over 2, and Megan, stop talking. X can equal negative 3, negative 2. Okay. Next part. Example 4, dividing rational expressions. Simplify and state restrictions. Okay, so here clearly there's going to be a lot of factoring with this one. So let's start off by put brackets around numerator and denominator, so you can do that. Factor it. X squared minus x minus 20. Okay, that is a easy trinomial. Oh, actually, sorry. I forgot to mention this. Division. So before we factor, one of the first things we can do is multiply it. So write out the whole thing again, which is a pain with this pad. X squared minus 5x. Okay, so I'm going to write multiplies. And now everything flips over. X squared minus 12x plus 36. Okay, and the denominator, x squared minus 12x plus 36. Okay. So, oh my god. There. Easy as pie. Okay. Factor this. So the top is a easy trinomial. What multiplies to negative 20? And what adds to negative 1? Your answer is negative 5 plus 4. The denominator, x squared minus 5x. Okay, so that's not a difference of square. 5x is not a perfect square. Common factoring. What is common to both terms? X. X minus 5 is what I'm left with. Okay, and of course you need your bracket for this one because it's x times x minus 5. Top right, the numerator in this rational expression, what multiplies to 36, adds to negative 12. That is in fact actually a perfect square. Remember perfect square? X squared is a perfect square. Square root is x. 36 is a perfect square. Square root is 6. 6 times x times 2 is 12. So this is a perfect square, which means it simplifies to one bracket, negative 6 squared. Even if you didn't recognize that was a perfect square, what multiplies to 36 adds to negative 12, negative 6, negative 6. So even if you didn't recognize it was a perfect square, you would still end up with one bracket. Okay. And, oh, okay, so someone probably noticed this huge mistake I made. That, I don't know why I wrote that out twice, that is here, plus 9x plus 20. And if I could go back and correct it, I would, but I am still recording. Okay, so sorry, forgot that mistake. I wonder if so many of you were just saying, Mr. Hall, what are you doing? Okay, x squared plus 9x plus 20. What multiplies to 20? What adds to 9? The answer is 5 and 4. X plus 5 and x plus 4. Okay. Factored it all. Everything's been factored now. Does anything cancel? Numerators and denominators. X minus 5, x minus 5, x plus 4, x plus 4. Okay, x minus 6 squared doesn't, x doesn't, x plus 5 doesn't. So, write that down now. X minus 6 squared over x times x plus 5. Okay, what are our restrictions now? Okay, so if you look at this, what are our restrictions? So if you look at the final part, we've got x can't equal 0, x plus 5 can't equal 0, therefore x can't equal negative 5. Okay, go to these denominators. X can't equal negative 5, we already have that one. What did we cancel? X can't equal 5. X can't equal negative 4. Okay, so we've got those ones. Okay, so if we just look at the denominators, we can say x can't equal 0, x can't equal 5, x can't equal negative 5, x can't equal negative 4. However, we are forgetting something. If you go back to the original part, remember, this was the denominator originally. Okay? It then got moved to the numerator. But at one point, it was the denominator, meaning this can't be 0. Meaning this can't be 0. So we have to look at the numerator in this case. So because we were dividing the rational expressions, you have to look at this denominator, which became the numerator when we multiplied. So x can equal 6 as well. So putting all that together in order smallest to largest, we've got negative 5 as a result of the x plus 5. We've got negative 4 from here. We've got 0. X can't equal 0. X can't equal 5. And finally, x can't equal 6. Okay, so the trick here was it's dividing, which means the denominator here became the numerator when we multiplied, but nevertheless it was the denominator in the beginning, so it cannot equal 0. Okay, I'm just thinking if there was another one I wanted to go over. Yes, okay. I think this is on your sheet, yeah. Okay. Multiplying, so we'll do this real fast. So we're multiplying, So we have to flip the second fraction and change it to multiplying, okay? It starts off dividing, so dividing by a fraction is same as multiplying by the reciprocal. So rewrite it as, okay, so I wrote very quickly there. Rewrite it as multiplying the reciprocal. Okay, first fraction, first rational expression. Can we factor anything from 6 over 8x minus 72? Well, 6 is a 6. Can't really break that down anymore. But 8 factors out of that first part. So factor out an 8. You're left with x minus, what is 72 divided by 8? It is 9. Times, numerator, 2x minus 18. Factor out a 2. X minus 9. Okay, oh, I see where this is going. X minus 9, x minus 9. And 9x. Okay, does anything cancel? The x minus 9 and the x minus 9 does. Okay, and you're also left with 6 times 2 over now 8 times 9x. So you might be able to see reducing numbers already. So I mean the 6 over 8 could change to a 3 over 4. So you could do that. I'm just going to bring it together first. 6 times 2 is 12. 8 times 9 is 72. Don't forget the x. 12 over 72x. Okay, does that reduce? It does. It reduces to, I believe, 1 over 6. Okay, so 12 goes into 72 6 times. So 1 over 6x. Okay, that is my final answer, but restrictions. Okay, so let's look at where we factored the denominators. However, remember, we divided. This was a denominator in the beginning. So that means once it's factored, we've got this can't be 0, x can't equal 9, x can't equal 0, and up here x can't equal 9. Okay, so x equals 9 was already covered, so that leaves us with x can't equal 0, comma, 9er. Okay, that is multiplying rational expressions. So tomorrow we will get into adding and subtracting rational expressions, which is actually a bit more challenging. So in this case, multiplying and dividing is simpler than adding and subtracting. And we will start to get to a few application problems tomorrow with the adding and subtracting. Okay, so hopefully this was an okay substitute for me not being there. So everyone should be good with this, and we will have the quiz on Wednesday. The quiz will not include anything from today, so anything from multiplying and dividing rational expressions, but it will have just simply factor this expression, simplify it, and also maybe some stuff from yesterday, which was simplifying rational expressions, which did involve factoring, but then canceling out terms and stating restrictions. Okay. That is it. Homework questions. Oh, if you didn't have that sheet, here it is. If you didn't print off the sheet, there it is, page 94, number 1 to 6, every other one, 12 and 14. Okay, so that should be good. All right, I will see you tomorrow. And actually use class time to get this stuff done, because I will check. All right, bye.